Hi guys, this is Tony from Inon, and today I'm going to be showing you a couple of fun things you can do with BQL. So BQL has a couple of uses. I've used some BQL to build this rather ugly but straightforward functional page here. I've used it to get some averages. I've used it to show the output of various meters on different floors. And the idea here is that if I add or remove floors, these are automatic, so I'll add another entry into the table and I'll be able to see what my energy use is. But that's not all. First, we'll have a look at how we use like the BQL query builder, because that's a good place to start and to build some BQL queries that you can then work from and learn to understand the what you type in to get a BQL working. Because there's a lot of use cases where BQL either saves you time or does something in a sort of programmatical way that makes a lot more sense for your setup. Usually your graphics or for you as an engineer to go and find things and work with them. So you probably use BQL for searches on the Niagara network when you connect to another device and you're looking for what points are on there. You might have used it for program service. But what it's really good at is generating tables of data and working with that data in a way that quickly gives you visual results. So first thing to have a look at what we can do with BQL is let's do something obvious, like let's try and find all of the devices that are overridden on my station. So go to File, Open, Query. Now you might not have used BQL in this from this menu before, but this gives you a nice starting place. Once you get used to BQL, once you've used it in Anger a bit more, you'll probably use the Control-L ORD editor in order to use it. So let's look for everything that counts as a control point. In config, I'll do the whole station. So we'll go for a match to begin with. So add one in there. This box is a little bit finicky, so it doesn't resize nicely after you add a match in. And what we're looking for is anything that's overridden. So let's go for out.status.is overridden. I'll explain how we find these in a second. And let's go for equals true. There we go. So I've got one thing that's overridden. It's this point here, drivers, Modbus TCP gateway, DODI points. Let's have a look at that. So I'm having to manually go and find it. Nequal is a little bit nicer because you can actually jump directly to the points. There aren't really any right-click options on a BQL search. And I can see it's this point that's overridden. So let's go Actions Auto. Click Refresh, and that should reload this BQL query. And there we go. So, quick way of finding all of the points that are overridden. Now, this one should be a bit more interesting because I know a lot of my points aren't connected at the moment. Let's Control L. So, I'm currently looking at this location. So, it's an empty BQL collection table, but it's looking for overridden points. As you may guess, we can also look for .isFault. Now, because I'm manually editing this, I should be okay to just press enter on isFault. Quick side note, if you've got like a Boolean thing, so when we're looking for points, and we're looking at an out.status.is something, it's either going to be true or it's going to be false. If I'm looking for everything where it's true, I don't need to sort of put in an equals true or equals fault, because it already assumes that I want the items that are in fault if I put is fault in there. In fact, if I want to find everything that isn't in fault, there we go, and I should find all of the points. I've got a load that are down but aren't in fault. But you can see you can do the putting equals false is really the only one that's useful, because that finds the points that aren't in fault. So let's go back to the builder and make a slightly more interesting search. This time I'm going to work with my meters. So I've got a whole load of simulated meters here. They do at least have an energy output that's slowly counting up, and it's got a random and that sort of thing. But this works. Obviously, this still works if it's a real point counting up energy use. So I'm going to go back to the open query. I can narrow this down so I don't need the is overridden. Narrow this down so that it's only looking at my meters. I'm going to pick columns this time. So the columns that we had for the previous search were just automatically generated. So we had something like this, where we've got sort of the slot path, which kind of should make sense to you. That's just the location of the item, same as you'd use in graphics. You've got the value, you know, the two, what it calls a two string, but that's the value in most cases. And then it sort of guesses at the rest. So we get facets, proxy, extension. Basically what it's done is it's looked at all of the points that returned and tried to guess what columns most of them will have in common. It can be useful, but it's sometimes less, it's a lot of the time less accurate than what you would want to put in there. So let's do a file open query, add in a couple of columns, clear out everything else we had in there. This time I'm just going to look for the name, displayed as name. Now the displayed as isn't necessary when you're editing it from in text. But when you're using the BQL query builder, it forces you to choose what name you want at the top of the columns. So, yeah, first column, we're going to put the name of the point. Second column, we're going to put in out.value. May as well put that as value. We're going to want to narrow this down to the meters because those are the ones we're interested in. And I'm going to add in a match. So I'm only interested in the points that are labeled energy. The other points are to set up the simulated points. So let's look for name, like. Can't remember if I put a capital or lowercase e. I think I put a capital. So I'm going to go for star energy. Let's click OK and see what we get. Okay, so that seems to be working. So we've got all of the points, all of the energy points. I don't know where they are at the moment, so I can add that in with a quick redo of the query. Let's put in parent.name, displayed as location, because the parent folder of each of these meters tells me which meter they're on. Maybe meter in that case. Let's go OK. And then maybe we want to move the columns around a bit, but let's do that with let's do that with Control L. So press Control L or click at the top, select name as name, out.value as value, and we can just move. Let's copy the comma as well. Parent name as meter. So this is, you know, this is what it looks for. This is what it puts at the top of the column. So the as command is it is useful. It makes your results look a bit more interesting. Let's go for that. We need a comma. So we need to select parent name. BQL select will be used in all of them. That's sort of the basic search. There's one other BQL command I know of, but BQL select is the one you'll see most often. That's just where the BQL starts. So we've got the parent name as meter, name as name. Let's go OK. Okay, so now we've got a list where, you know, it tells us what meter, gives us the name of the point, but actually we probably don't need that either. And then the number. There we go. So there's a basic search for everything that's a meter and has a point called energy. Let's do something a bit more interesting. So let's assume you want to find out the average of all of these energy points. So let's Control L. This is slightly easier than using the editor if I've already got a BQL table on my screen. Right, I'm going to remove the parent name. Now that's important. At the moment, I'm showing all of the meter names so that I know which meter each of the points came from. In this case, I'm going to leave the name in, but I'm going to look for the average of the out.value. And we do that like this. So we put AVG is the keyword to generate an average. Whenever you're using an aggregation function, like average, like the average, you put in brackets what you want to average. So the out.value is going to be, I'm looking for all of the energy points, so I know they're all going to have out.values, and that's going to be the energy usage, and I'm going to work out what the average is from all of those points. Click OK. All right. Okay, so I've done a bit of movie magic, and I've moved all of my meters into different floors, so ground, first, and second floor. These are just folders, but it's going to allow me to do something a bit more interesting with this average or this aggregation function I've got. So let's say we've got these 3 different floors and we want to see the energy used per floor, the averages, the minimums, the maximums, and so on. We already know how we do an average, so we can Control L to adjust the BQL query we have here. So obviously we've got BQL select and then the breakdown of the columns we want. And we're going to want to change some of these. So if we put in things that are going to be unique, now at the moment, if you look in the background, I've got an average energy value. Should have put a nicer name on it, but I've got an average energy value for every point named energy in the station. And that's basically because I'm looking for anything that's called energy. I want to keep that part, but instead of collapsing them all into one block and working out the average of that, by changing what columns I'm looking for, I can actually get the BQL query to return a set of results by another property of the points. So in this case, I've intentionally moved the meters into ground floor, second floor, first floor. So if we look for what should be the parent dot name, so I'm looking at the points named energy, their parent will be named whatever the meter is, but their parent dot parent, because these are all in the meters. I can't show you at the moment, but they're still in the meter folders. The parent dot name will be ground floor, first floor, second floor because of the way I've structured this item. So let's give this a go. There we are. So I've got 3 different areas, and the BQL search is working out the average energy used on each floor. So that's the first step. That gives me some interesting output. I can see that the second floor is using more than the rest. Sorry, it's using a higher average than the rest. This doesn't tell me necessarily which one's using more energy, because the individual meters might be going to different, maybe different rooms, different sets of equipment. So let's add in some more aggregate functions. So we're basically taking the average out. I'm going to remove the adds value because that just puts the name at the top. Click OK. Tells me it's average out.value. Maybe I want to put in average. Let's go for min. So you have to make sure you're spelling these words correctly. Sometimes you'll see them uppercase, sometimes you'll see them lowercase. Niagara actually doesn't notice the case for the aggregate functions. So out.value. Yes, there's a lot of typing out.value when you're doing this. Or you can copy paste, obviously, as maximum. And click OK. There we go. So we can see there's some interesting things happening. Above 80,000. So second floor has a high average. It actually has a lower minimum value and a larger maximum value. So we're learning a little bit about these floors. The second floor seems to have a wider spread, but also it has a slightly higher set of values. Let's add in another aggregate function, which is sum. We found what the average of the energy meters is, minimum, maximum. The sum will give us an idea of how much in total we're using per floor. Sum out.value as total. And there we go. And we can see that the second floor, as well as having the highest average and the broadest spread across the values, it actually has a lot more total energy being used on that floor, and that is because I just happen to move more meters into there. So it's an arbitrary example, but you can see how you can sort of get started with the aggregates in BQL. Now, you might be wondering why you would bother doing this, because the moment I move to another page, it's going to lose that BQL search. Well, one of the most common uses of BQL for something like, sort of seeing the total energy as a chart, is just to add in a link. So we can we can cut that item. We can go to sort of our meters page, and we can add in a label at the bottom here. Floor aggregation. And stick this in as like the hyperlink ord. Make it look like a link somehow. Blue. I don't know. Sort of hyperlinky. You can obviously do a hyperlink however you like. Do it as a button or that sort of thing. This is kind of very 1990s internet. But there we go. So we can jump to the aggregation. We can give the end user a quick jump so that they can have a quick look at so a basic BQL use case here. Okay, so let's put this as a widget on the page. So we've got a couple of options. We can use the link, just copied and pasted from that, or we can sort of, if I split this into two, and I want the top half to show the aggregation of the different floors. So I'm going to need, this is where we need something from a slightly unusual palette. So from the Badger UI palette, if I go and grab a bound table, other options are available, but I just want to show you this one. And then the bound table, we add a table binding, and we bind it to the thing we just copy pasted, and it'll draw it on the page at the top. So I probably want to put a label on there to tell people what they're looking at. But that's some things you can do with the aggregation functions in BQL. So I'm going to start with a fresh page. Let's do something a bit more tricky with BQL. So I know that I've got a number of folders here, and inside the folders I've got a number of meters. And I just want to sort of stick in some bound tables, one for each floor. So let's move this up here. This will be my ground floor. Actually, let's move it down here because it's the ground floor. And let's build a BQL from scratch. So add in a table binding. And I'm going to do this somewhat blind, but this is something you sort of learn as you use BQL. So I'm going to go for BQL select. So I'm going to BQL select display name and the energy.out.value from Baja folder. So what I'm attempting to do here, and we'll see if it works or not, I'm going to grab everything that's a folder from inside the meters. So let's put on slot. Where am I now? I'm in meters. So I can just go for slot. I can then add in a bar character. Bar character is important. You've seen these all over the place in the ords you've already used. And it sort of separates out a second scheme. So if we go for slot, so we tell it that we're interested in this location that we're currently in, so that's where the graphic is. But when we're in there, we want to do this BQL query. So we grab the folders, which should be, probably want to change the slot slightly, so it's looking at, for this one, we want to look at ground floor. So it'll start in ground floor, and then it will select, we ignore the columns for now, and then down the end where we got from, we look for everything that's a folder, and we get the display name and the energy.out.value. Now that should work. The reason I know energy.out.value should work is that when it goes through and it finds the folder, so use meter 1 as an example, it goes into there, it looks for a slot called energy, and all of these have a slot called energy because they're duplicates. So it gets this numeric writable here, and it gets the out.value, same as you're used to from that energy. So we can put slightly more complicated searches in here. Let's click OK. Let's click OK. And we should be able to duplicate this. So Control D to duplicate. And change this to be first floor. However I spelt it. Go OK. Now it's got different meters because it's in a different floor. And we can do the same for the second floor. Okay, I probably want to put something in here. Let's be incredibly lazy and just use the A to B switcher in the bound ords to change these. And what we're looking for is, where can we put it? After energy.value. So energy.out.value. Replace with the same thing. Add a comma. So now you can see on the ords here, I'm basically going to add another slot, energy.out.value. I probably put this in the front, but I didn't think of that at the time. And then parent.display name. It'll be the same for all of the things, but again, we're using our knowledge of the Niagara system to say that if we're looking at our Baja folders, so we're inside ground floor, we're looking at all the meters. As an example, we know that if we go to the parent, we go back up to ground floor and we show the display name and click OK. Now we've got, it's a little bit more obvious to somebody looking at this page that these meters are on the second floor. I probably want to change the titles at the top. I can go through here and I can add like, I'll leave display name, but I'll put in parent display name. Now remember, when we first looked at it, we had BQL Query Builder, we had those names. And it put those names on by putting as after the particular point. So parent.display name is this one here that says display name at the moment. As floor. Let's go OK. And then, yeah, the one I've got highlighted, I didn't do it for all of them, but the one I've got highlighted now says display name, value, and floor. So there's a lot you can do with BQL, and the more you use it, the more you'll understand what it's useful for. We can also use text boxes, so I'm going to do it on the page I've already got. But this is actually really useful for setting up other graphics. You don't need to have the tables here. I just happen to have tables on this page I'm creating. Now I want to show next to these blocks that are showing me each floor, they're showing me each individual floor and telling me the value of each meter. I also want to put in some aggregation, but I don't want that really to be in the graphic. I want to have like a separate thing here that tells me that. So let's add on a bound label. It's going to need a binding. And we're going to bind this to, okay, we're going to bind this to the same thing, but we're going to modify it. So let's go for, let's move that down to the ground floor and copy the ground floor ord. But this time, I'm only interested in the aggregate. So so I can remove most of this out. I'm going to keep energy.out.value because that I know that worked. And I'm going to make this into an aggregate. So I'm going to average energy out.value. So they get the average for the ground floor from bar half folder. Yeah, that's fine. I know that most of this will work because I've already tested it. I'm going to click OK. I'm going to click OK. I'm going to click OK, and I'm going to animate the text. And I'm going to put in floor average energy use %.%. Click OK. Click OK. And I'm not expecting this to work. So I've got floor average energy use. And what Niagara does, if you feed it a BQL select, is it produces a data table. Yeah, it produces something that looks like this. That doesn't work for putting into a label, but actually there's sort of a built-in secret where we can select, even though this only gives us one value, we can tell it that we just want that one value. So we do that for the ord itself. Right at the end here, if I put in another pipe character, now remember a pipe character tells it with the previous thing that it did to do something else. And in this case, we're going to go for one of the, there's only one use case I've ever had for using the cell schema. And that is to say, select row 0, column 0. And what we've done here is we've basically turned this BQL search that gives us a table with only one thing in it, the average of the energy out values, and we tell Niagara that we just want one value out of it, the value at row 0 and column 0, so like the very first value. Let's click OK, and there we go. So we now have a floor average energy use, and we can copy that for the other floors, and we can make it prettier, obviously. My default is to be quite texty on these. Okay, there is obviously a lot more you can do with BQL. I've just shown you sort of some starting points. You can basically access anything that's in the Baja system in general, but hopefully it gives you sort of a starting point and at least gives you some ideas of what you can use BQL for. And hopefully I've given you some ideas that sort of anyone who's working with Niagara can look at and say, oh, I didn't know it could do that. Okay, thank you guys. I'll speak soon.